Hello everyone, my name is Harish Chandra and I'm excited to walk you through my MLOps capstone project titled Voyage Analytics. This project is focused on applying machine learning and MLOps practices in context of travel and tourism industry. The main objective of this project is not to build perfect or highly optimized models, but rather to demonstrate the end-to-end pipeline automation and scalability of ML systems using tools like Docker, Jenkins, MLflow, Airflow, and Kubernetes. So while the model matrices may not be fully optimized, the core focus is on implementing production-grade MLOps practices, ensuring the entire machine learning lifecycle is reproducible, scalable, and manageable in the real world environment. So, as we all know, the travel industry is undergoing rapid transformation, and the data driven decision making is becoming a key differentiator. This project leverages real world dataset to build and deploy intelligent systems that enhances the travel experience by enabling a smarter decision from flight booking to selecting hotels. Now, the overall objective of this capstone project is twofold. One is build predictive and recommendation model using real world data, and second is to implement and demonstrate the complete MLOps lifecycle, including model training, containerization, CI/CD, orchestration, tracking, and deployment. The project is divided into three components. First, a flight price prediction model to estimate airfare using travel metadata. Second is the gender classification model to classify a user based on their profile attributes. The third one is a model, a hotel recommendation system to suggest hotels based on content similarity and the user preferences. While all three components have been implemented, but this video will be especially focused on the regression model for flight price prediction, demonstrating its full MLOps lifecycle, including model development, deployment, scaling, automation, and monitoring. So let's begin with a quick overview of the project architecture and the dataset that power these systems. Let me share my screen. So this project is designed to simulate a real-world machine learning production workflow in the travel domain. So the idea is not to just build the model, but also to integrate it into the robust, automated, and scalable MLOps pipeline, which is the core focus of this capstone. The project is based on three core datasets. First is users, then flights, and then hotels dataset. Each one offers a unique perspective on the travel behavior and allows us to design specialized models. Here is a quick overview of the each dataset. So the first dataset that we discussed is the users dataset, wherein we have the user code, company name, name of the user, gender, and its age. Then we have the hotels dataset, wherein we have the travel code, user code, name, place, days, price, total amount, and the date. And the final one is we have the flights dataset. In the flights dataset, we have the travel code, user code from the departure point and to the destination point, and the flight type, price, time, distance, agency, and date. So these are the all three data sets that been used for each model. So these three have been used for different models, but all three models are been interrelated. So the first model that we have built is the flight price prediction, which is a regression model. So if I show you the flights price prediction models, how it looks like, so here it is. So this model predicts the price of the flight based on the features like route, type, agency, and the travel metadata. It uses a random forest regressor, and which is the central focus of this video. Next is the gender classifier. So if I show you, so we do have the gender classifier here. This is the app.py file. We have this one as a training module. Yeah. So this gender classification model classifies the user's gender using the name, age, and the company. It's built with a random forest classifier and includes the web interface for interaction. So if I show you the web interface that is here, yeah, this is the web interface that is being used for this classifier, this gender classifier. And the last one that we have is recommendation model. So the third and the last model, that is recommendation model. So this system suggests the similar hotels using the content based filtering, especially TF-IDF and the cosine similarity on the hotel name and the location. It's served by a Streamlit web app. So, throughout this project, I have used a wide range of tools, as you have seen in the codes. So, for the model development, I have used Python, Pandas, and scikit-learn. And then for to serve the models, I have used Flask, Streamlit, and for the containerization and orchestration, the Docker Compose, Kubernetes have been used, and then for CI/CD pipelines, Jenkins have been used, and finally for workflow automation, Apache Airflow have been used, and finally for tracking the models, MLflow have been used. So these tools not only help in managing the MLflow lifecycle, but also ensures that the solution is scalable, reproducible, and production ready. Now that we have covered the data sets, models, and the tools involved, let's begin our deep dive into the flight's price prediction system, starting with the model development and evaluation. So let me move ahead towards this. Just let me close all of these, which is not being in the focus. So we do have this one now.
So, the first component of this project is a regression model designed to predict the price of flight based on the features like origin, destination, travel type, agency, and the distance. So, if I show you the entire structure of the model, which looks like something like this. So, here we have the entire structure of the project. Now, in this, for data pre-processing, let me first open the file, which is here, the training is. Yeah. So for the data pre-processing, I have converted the date fields into the date time and extracted the important features like month, day, and so on, and then dropped the irrelevant columns, and then applied one hot encoding to the categorical variable. Post that, I used random forest regressor for the price prediction task and split the data into 80 and 80 for training and 20 for the testing. For then for evaluation, I used RMSC and R square to access the model's performance. Once the model was trained, I saved it into the job file, uh, which is named as this model of flight price model dot pickle file. Now, with the model trained and ready and saved, the next step was to expose it using REST API for the real-time interference. Let's take a look into that. So here is our app.py file wherein I have called this or they loaded this joblib file. Then using this joblib, there are two routes. One is the slash blank root, which is used for checking the health of the our this API. If we are getting 200 response with this route, then the API is working perfectly. And then used the predict route where which was exposed via post method, wherein we will get the user can input the JSON data required fields, and then we can return him the uh, predicted value. Here we are returning him the predicted value. So this is the two things, major two things. First, creating the model, training the model, and setting up and then saving it as a pickle file, and then exposing it to the outer world using the Flask API is completed. Now the next step is to containerize it and further deploy it over the cloud. So let's deep dive into that. So to make sure that the application runs consistently across different environments, I containerize the entire project using Docker. So this includes both the model training script and the Flask API. So if I show you my Docker file, so here it is. So in this, the entire the the entire Flask API and the model both have been Dockerized and deployed. So I created two separate Docker files, one for the training of the model, here it is, and another one for the Flask API using Gunicorn and as the WSGI server. So now with the API containerized and portable, the next step is to automate the workflow using CI/CD pipeline with the Jenkins. So now let me show my Jenkins file here, and I'll explain how I automated this entire pipeline. So to automate the entire machine learning development workflow, I implemented CI/CD pipeline using Jenkins. This ensures that the model training to build the deployment training to building and deploying the Docker container. So here is the Jenkins file defined in Jenkins file. It's the declarative pipeline that runs the following stages. First, check out the code. Then second, install the Python dependencies. And third one is the train flight price prediction model. Then fourth is build Docker image. And the fifth one, which is optional, but we would have done it, like we can push it for the Docker hub and for the registry and to deploy it. So this pipeline majorly removes the manual stages from the development with just the commit or the click of the button. We can retrain the model and deploy the entire container. So this is very reliable and reproducible. As the next step, I'll show how the model matrices and parameters and versions are tracked using MLflow, enabling the experiment tracking and the reproducibility. So let me show my MLflow files. Okay. So to keep the track of my experiments, I integrated MLflow into the regression model for flow. So MLflow helps in monitoring the model parameters, matrices, artifacts, and the versions, making it easy to compare and different run and reproduce the results. So here is the code that I used to log the model matrices over the MLflow, and then let me show you the screens of MLflow how it was having over there. So these are the screens of all the runs that I have done over there. So these are the runs that is being done over here. These are the two matrices that we were discussing about, and this was the log over there. and this was the ML model. So here it is. This is the conda.yaml file and this Python environment.yaml file, and yeah, this is requirement.txt. This is the all about MLflow. Now, as the next step, let's move ahead and now talk about the next thing, which is the uh, Apache Airflow. So now that we have tracked the model and model version performance, let's look at how I automated the entire pipeline using Apache Airflow. So if I show you here, let it be load properly. Yep. So in the uh, this docker dot compose regression Kubernetes. Yeah, although these are the MLflow uh, runs, and then we have these the files that we were looking at the UI. Okay, so finally, we were at Kubernetes. So no, not at Kubernetes. We were at Airflow. So if I show you my Apache screen, so these were like something this. So these were the Airflow screens. This is the Airflow container in the Docker itself, and this is the deployed model over there. So you can see the steps. This is the successful run, and here is all the history of the runs, and then this is the rag file. So I'm not able to track the YAML file. My this is the flight model training which is over there, and this is the runs, different runs that we have done. This is the log of the run, and this is the time taken, time duration for the each runs. So here is all about our ML flow, our Apache Airflow. So now that the pipeline is automated and the trackable, let's move to how I deployed the application on Kubernetes scaling and containerization. So let me show you the deployment.yaml file. So in the Airflow, we have this Docker compose YAML file. So here is the deployment.yaml file that is being used to deploy the Kubernetes for the Flask API. So to deploy it, I used ctl apply minus f deployment.yaml, whatever the file name is, and Kubernetes then create the pods and expose the service. Once the deployed Flask API can be exposed through the port on the Kubernetes node. So with the Kubernetes, the app can scale easily by increasing the replicas, and it can recover from failure automatically, making it truly production grade. Now that all components from training to deployment and scaling are in place, I'll conclude this with the quick project summary and the final thought. So let me share my Word document that is being prepared for the same purpose. Here is, yeah. Okay. So this is the Word document that is being prepared for the purpose. You can go through it, and just to summarize this project demonstrate the complete life cycle of deploying a machine learning model in a real world production setup. especially with the travel domain. I implemented three key components. First is the flight price prediction model, and using the regression, and then the gender classification model, and then the hotel recommendation model. But the focus of this video was only the regression model, showcasing the full MLOps workflow for the same. Now, from model training and the evaluation to deploying it with the API, containerizing it with Docker, automating workflows with the Jenkins and Airflow, tracking experiments with the MLflow, and finally scaling it to Kubernetes. Every major MLOps component was integrated and demonstrated. This project has been a great hands-on experience, not just building the machine learning models, but also truly operationalizing them using the industry-grade tools. It reflects the strong understanding of the machine learning end-to-end machine learning system designs, automation, and the production deployment. Thank you so much for the watching. The full code and the documentation are available on my GitHub repository, and I hope you find this to walk through valuable. Thank you so much.